Okay, we have part two of our tutorial on projectile motion, and this one is going to be a little bit different. We have a small rocket that is launched off a 100-meter tall building, and it tells us that the rocket has a initial velocity of 45 meters per second, and its trajectory is 50 degrees. Then it wants us to find the total time the rocket is in the air, the maximum height of the rocket from the ground, what is the maximum range, that'd be from the building and to where it hits the ground, and then find the velocity of the rocket at the ground when it comes back. So the scenario we have is this right here, where we shoot a rocket off the building and it lands on the ground somewhere down here, and we have our initial velocity and our angle. Now, one thing should be noted that in this area before we start here, this is the y-axis, this is the x, and this is right here where the launch occurs. That is the, this is the point of launch right there. Okay. Okay, so let me just put down for the y equivalent, this be actually negative 100, where this would be 0 right here. Okay, so let's do this problem. Okay, so the first thing that it asks us to do is find the total time the rocket is in the air. So let me, okay. So to find the total time the rocket is in the air, we need to have an equation that we can use. Okay. And that equation is going to be delta y equals v synod sine 50 degrees times t minus 1/2 g t squared. Keeping in mind the minus there is because of the gravity. Okay. So now I want to solve for t. Okay, so how do I do that? Well, I have to use a quadratic equation. So I need to set this equation up in a form that's equal to a quadratic equation. So 0 is going to be equal to minus 1/2 g t squared plus v naught sine 50 degrees. And then the y is equal to negative 100. So our y is equal to negative 100, but since we're going to put it on the other side of the equal signs, it's going to become plus 100. So now we have our a, b, and c for the quadratic equation. So let's put that down. So 1/2 gt, so this is minus 4.9 t squared plus 45 meters per second times the sine of 50 degrees t plus 100 meters. Let's break this down further again. Minus 4.9 t squared plus 34.47. This is the 45 meters per second times the sine of 50 degrees. T plus 100 meters. Okay. So let's keep on going here. So now we need to solve for this quadratic equation. And you remember the quadratic equation is b plus or minus e squared minus 4ac all divided by 2a. So let's go ahead and plug all that in there. So we have minus 34.47 plus or minus, this would be the square root of 34.47 squared 4 times minus 4.9 times 100, all divided by negative 9.8. Okay, so when you solve this problem, you're going to get two answers. One is going to be a negative number. So you're going to get negative 2.20. Okay, and then you're going to get also 9.24. So the time is going to be the positive one, 92.4 seconds. Okay. So that is the time that the projectile from the top of the roof being shot off, coming down and falling on the ground, how long it takes. So now let's look at the next one. And this wants us to find the maximum height of the rocket from the ground level. So that would be, the maximum height would be from this point up here, at the very top, to the ground, not the top of the building, but to the ground. Okay, so let's do that one. So we need to first find the maximum height in the positive part of the curve. So what does that mean? Well, it's coming off the building. Let me put this in red. It's coming off the building, and then it reaches the level part that is at the same height of the building right here. Say this is a building right here. And then it's coming down to where it hits the ground. Okay, so this right here, we have the 50 degrees is our angle, that our vector angle of the initial velocity of 45 meters per second. Okay, so we can first solve the maximum height from here to here. And we know that the height from here to here is 100 meters. Okay, so we just need to find this height and add it to this. So we can use v squared minus v squared equals minus 2g delta h. And I'll change color. We're going to say that v synod is going to be equal to 0. So we have to set this equation up right here. It'll work. So if the initial value is 0, then this right here would be v synod sine 50 degrees squared is going to be equal to minus 2 times g, and this will say this is this y. Okay, and so now we need to solve for y. Now this y, we can call this y1 if we want, and we can call this distance y2. So y2 plus y1 will equal y max. Okay, so let's do that. So we just solve for y. And this y we're solving for is y1. Okay. And this is going to be equal to v synod sine 50 degrees squared divided by 2g. So this is 45 meters per second sine 50 degrees. All this gets squared divided by 19.6 meters per second squared. Keep our units, and we find that y1 is going to be equal to 60.6 meters. So what is y2 or y max? Y max is equal to 100 meters of the building, for the building, plus 60.6 meters, giving us 160.6 meters, and that's our final answer. So that's the total height from as high as the rocket goes to the ground. Okay, let's move on to the next part. What is the maximum range to rocket horizontally from the launch of the building to the ground? Now we got to keep in mind velocity in the x is always constant. So if that's the case, then this equation would be true. So say we got to pick the right numbers. So let's do that. First of all, this is our x max then, and we solve it by what's v? Well, v is going to be v synod cosine 50 degrees times, and only times, t max, the maximum time the projectile is in the air. This will give us what we're looking for. So this is 45.0 meters per second times the cosine 50 degrees, and this is times the time, which we got in the last part, 9.24, part A. Okay, so multiplying this out, we get 267 meters. So now we solved for part C. Okay, so again, going back to the diagram up here, that would be from top to x would be from there to there. That would be x max. Okay, let's do the last part of this problem. That is to find the velocity of the rocket at the ground. Okay, so there's a couple ways to do this. I'm going to show you the easiest way. Okay, so we're going to go ahead and we're going to use this equation. Where y in this case will actually equal y max. Okay, so I'll just call the y is basically going to be y max from what we saw from last time when we did the maximum height. Okay, we got to notice though, okay, what about b squared and b squared, b squared not? Okay, this is going to be in the vertical y. So we have, first of all, we have the initial velocity is going to be 0 up here. This is going to be 0. And then we're going to have this velocity, which is going to be the v that we're looking for. Okay, v sine 50 degrees is the final velocity. Okay, and so this right here, all this gets squared, minus 0 equals minus 2g delta y, or y max. And now we need to solve for v. Okay, and let's do that. So v is going to be equal to 2g y, that's going to be the y max or delta y, all divided by the sine of 50 degrees squared, and this is all going to be the square root. Okay, so let me solve it now. I plug in the values. 2 times 9.8 meters per second squared. Now our height, our total height was 160.6 meters. And this, if we, the sine of 50 degrees is 0.7660, we need to square that. Okay, and then this whole thing is the square root. Now one thing I want to go back, and I kind of missed, is that there was a negative sign here. So we want to pull that negative sign out of the radical. So this would be negative equals to b. Okay. So let me calculate the value that we get. And so v, the velocity when it hits the ground, is going to be equal to 64.1 meters per second. So that is our answer to this problem. And so actually in part 1, we did this first part of if the building was at ground level and coming over here with the 50 degree incline or trajectory, and also with the 45 meters per second. We found that out to be 60.6. And by the way, when that comes down, when it's right across from the building, for instance, right here, taking this trajectory all the way here, the velocity right here is going to be equal to the initial velocity of 45 meters per second. Okay. And time it gets down here, now it's going to be 64.1 meters per second. And we can say negative because it's going down. Same thing over here, negative. And that's the direction in that axis, okay? And actually, just one more thing I want to bring up. This V, you got to remember this V right here, this 64.1 meters per second is actually the velocity of it coming down like this. Okay, where this is the y-axis and this is the x. So this is not the velocity that's in the y. Because if you look and see how we solve this problem, up here we had v sine 50 degrees. What is this equal to? Well, this right here is equal to V synod y. Okay, and we didn't use that value. We use this, and so this V right here is the V that's in both dimensions. Down here, and it's in a minus direction. So this is what we found, this vector right here. Okay, I hope that helped you a little bit. That's the end of projectile motion tutorials. Thank you.